All right, so today we are talking about still investments, but it's going to be the future value of investments. And the biggest difference between what we did last time and what we're doing this time is today we are talking about periodic deposits. So a periodic investment is where you make a regular, like a scheduled deposit or a repeat deposit. Oops, that should be a T. So this is like, imagine you want to save up for something, and so you're going to deposit a certain amount of money every month into an account to save up for it, or every year, or something like that. So like what we did last time, you were just making one deposit into an account and letting it grow in that investment. Today, we're talking about if you are continually depositing a set amount into an account, what will happen. So for today, we are going to be using this formula right here for most of the time. And again, this is if you are making periodic deposits. Now, part of what we do today is going to be making sure we can identify which formula do we use. Are we making repeated deposits? Then we want to use this formula. Are we making one deposit and the interest is being compounded? Then we're doing it like we did in the last lesson. And we'll also review simple interest as well, so you can kind of look at those three formulas and determine when do I use which one. So the good news is with this formula, most of it is going to stand for the exact same things as it did in the last lesson. So the B still stands for the ending balance. How much money is in the account now? P, this is the new thing. P is going to be the periodic deposit. So how much are you repeatedly depositing? That's the P value. R is still going to be the interest rate. And just like always, it's in decimal form. N is going to be the number of times compounded, just like before. So compounded per year. So for instance, if it's compounding annually, N will equal 1. Semi-annually, 2 times per year. Quarterly, 4 times per year. Monthly will be 12 times per year. Weekly is 52, and daily would be 365. Those are the different values you would use for N, depending on how often it's being compounded. And then the last thing, time. The T stands for time, and still we're measuring this in years. Okay, so let's look at our first example. Rich and Laura are both 45 years old. They open an account at the Rhinebeck Bank with the hope that it will gain enough interest by their retirement at the age of 65. They deposit $5,000 each year. That is crucial. Each year, they're not putting it in one time. Every single year, they're going to deposit $5,000 into an account that pays 1.25% interest. So that sounds like our interest rate, compounded annually. What is the account balance when Rich and Laura retire? Okay, so first thing, we are looking for what is the account balance. So B, we don't know that. That's what we're going to find. P, they are depositing $5,000 each year. So that P is a periodic deposit. The interest rate, in the problem it said 1.25%. We're going to move that decimal, divide it by 100. So in our formula, we'll use 0.0125. Compounded annually, so that means N is going to equal 1. And let's talk about the time too. It didn't say like a specific number of years, but you got to kind of use some reasoning skills, okay? So they are 45 years old and they want to retire at the age of 65. So the time is going to be the difference between 65 and 45. They have 20 years to do this. 65 minus 45, they're going to deposit this money into the account for 20 years. So T will equal 20. Okay, now I'm using that new formula. So B equals, and then if I go up a little bit to see my formula, it says P, so 5,000. And then those double parentheses are important. The 1 plus will always be there, and there's that fraction. In the top of the fraction, we put R, 0.0125. In the bottom, we put N, which is 1. Okay, and then I'm going to close the parenthesis. And, ooh, I'm kind of running out of room. Okay, so in my exponent, I'm going to have N times T, and then minus 1. Close my parentheses. Sorry, I kind of had to squish that in. And this is all going to be divided by another fraction. Okay, I need to fill out my exponent. So N was 1 and T is 20. So that's 1 times 20. Sorry, that's so hard to read. This is a 20 right there because that was my time. And then in the bottom, it's divided by R, 0.0125 over N again, which is 1. Okay, now this is a tricky thing to plug in your calculator. I'm going to tell you right now, grab your calculator and try and type this in. You should get 112,814.892 in your calculator. Try and type it in. Now, when you grab your calculator, the very first button you want to push is that fraction button. Start with a fraction, that N over D button, and then type in the whole top. Use the parentheses, type it in exactly like you see it, and then arrow down, hit the fraction button again to get a fraction in the bottom. If you want me to help you plug it into your calculator right now, pause the video, let's work it, and make sure that we get 112,814 in your calculator before you move on. So our calculator gave us this number, so our solution will be the amount of money they have in their account would be $112,814. And let's round this to the nearest cent. So after the 9 comes a 2, so I'll just keep it 0.89. This would be our solution. So if they deposit $5,000 into their account every year for 20 years, that's how much money they would have. All right, next example. Bob invests $1,500 into an account with an interest rate at 4% compounded annually. Find the account balance in 2 years. Okay, pay attention right here. It says he's investing $1,500 into an account, period. He's not doing it over and over again. He is just investing that $1,500 one time. So one deposit of $1,500. It's not a repeated deposit. So I am using not today's formula. I'm using the old formula from yesterday. The B equals P times 1 plus R over N to the N T power. That's the formula I'm using. Okay. B, still ending balance. I want to find the account balance. So that's my question mark. P is that one-time deposit of $1,500. R, interest rate of 4%. Move the decimal though, so this would be 0.04. N, still how often it's compounding, compounded annually, so N would equal 1. And T, we want to find the balance in 2 years, so T would equal 2. Okay, so now if I plug into this formula, I'm going to have B equals P, which is 1,500 times 1. Remember that 1 is always there, plus the fraction. R goes in the top, 0.04 over N, which is 1. Close the parenthesis, and then my exponent is going to be N times T. N, remember, was 1, and T is 2. So this will be 1 times 2 in my parentheses. Type that into your calculator, and we should find that B equals $1,622.40. So that would be my solution. in 2 years, that's how much money would be in his account. And again, I used this formula from the last lesson because it was just $1,500 deposited into the account one time, not repeatedly. Okay, next example. Linda and Rob open an online savings account that has a 1.4% annual interest rate compounded monthly if they deposit $1,200 every month. See that right there? That's a repeated deposit. So that means I'm using the formula from today, right? The B equals P times 1 plus R over N to the N T power, and then we minus 1 and we close that parenthesis for the top, and then we divide it by R over N. Okay, and then we talk about each of the different pieces we need. So they're asking us how much will be in the account. So that means we don't know what B equals. P, how much are they repeatedly depositing? They're depositing $1,200 each month. So P is going to be $1,200. R, the interest rate is 1.4%. Remember to move the decimal though, so that'll be 0.014. N, this is compounded monthly this time, 12 months in a year, so N will equal 12. And T, we want to find the account balance after 10 years, so T will equal 10. Okay, so I'm going to plug this into my formula. So I'll have B equals P, 1,200, times 2 parentheses, 1 plus the fraction, R, 0.014, divided by N, which is 12. This parentheses should probably be a little bit bigger. To the N, 12 times 10 for T. Remember, those are being multiplied in the exponent. And then we get out of the exponent minus 1, close the parenthesis. And we're going to divide this by the fraction, R, 0.014, divided by 12, because 12 is how often it's being compounded. When you type that into your calculator, you should find that B equals 154,470.791. And again, if you're not getting that in your calculator, ask me to come help you now, please. So your solution, how much will be in the account after 10 years? $154,470.79. After the 9 comes just 1, so we'll keep it 0.79. And that would be our answer. All right, next example. Rob and Linda's account. So this is that same account from before, the one we just barely did. That's the same Rob and Linda. P equals 1,200, R equals 0.014, N equals 12, T equals 10. That's all the same stuff I just barely wrote down. This time, though, it says write a future value of the function if X represents the number of years. Okay, so basically I'm going to take this formula from before, but I'm not going to say T equals 10. Instead, I'm going to say T equals X. So when I do that, I will have B equals 1,200 times 1 plus 0.014 divided by 12 to the 12x instead of 10. Minus 1 divided by 0.014 divided by 12. All of that stays the same. Okay, now what I'm going to do is I'm going to use a graphing calculator. I'm going to type that equation right there into my graphing calculator to see a graph of the future value. So I'm going to go to Desmos. You can go to Desmos too if you want, or you can just watch. So let's see. So I just typed in desmos.com, and then I want to open the graphing calculator. Okay, and right here I'm going to type in 1200, actually, correction. I'm going to start with a fraction. So, oops, I don't want that. I want a fraction, so I'm going to hit my divided by button. There we go. Now I'll get my fraction. 1200, and then parenthesis, 1 plus, oh, not minus, plus 0.014 divided by 12. Oh, I lost my 0.4. Okay, and then I'm going to arrow over here and close my parenthesis. And then my exponent button, I'm going to hit this A to the B. See, that gives me an exponent, and I'm going to type in 12 times x. Okay, and then I'm going to push it down a little bit. Notice how it's not up in the exponent anymore, and type -1. Close my parenthesis, and then I'll click over here so I'm down in the denominator. And I'm going to hit the fraction again, the divide by button, 0.014 divided by 12. Okay, and you'll notice there's this blue thing on my graph, but it is not a great picture. On your paper, there were some like scales on the x-axis and the y-axis. If I hit this button that looks like a wrench, it's going to open up the settings, and I'm going to change my x and y axis values to match the picture because I know those are going to show me a better graph. So for my x values, I'm going to say let's go from -1 to 10. And for my y values, I'm going to say let's go from -1000 to 21,000. And then I'm going to say let's label every 5,000 is what we did before. Never mind. That's probably fine. Okay, now where is my graph? Why is this not working? Oh, I think I lost my point right here. That's important. There we go. And just double checking my work, making sure everything looks right. 1200. Okay, so looking at my graph, I want to check this point right here. Oh, I think there's what my problem is. I lost, nope. Oh, I don't want to go to 21,000. I want to go to, this is it. I'm missing a 0. Let's go to 210,000. There we go. That's what I'm looking for. Okay, so now I can graph this. Okay, so a couple of points I'm going to point out. So like right here, 1. Okay, so like T is, well, I guess my x-axis represents the number of years, right? So after 1 year in the account, there's $14,492. After 2 years, there's $29,189. 3 years, 4 years, and 5 years. Write this number down. Write that point. 5, 70, where'd it go? 74,500 $34.83. Write that down. We're going to need that, okay? So that's the picture. We're going to plot some points and graph that. Going back to my notes. Here we go. Okay. So that first point, well, notice, I guess we should have talked about it. Did you notice it started at the origin, 0, 0? And then there was this other point, like 1 comma, so here's 1. And then it was like 14,000. This is 50,000 up here, so these are counting by 10. So 10, 20 would be like about right here. And then 2 was about 30,000. 3 was like 44,000. And 5, this one was important. This is the one I told you to write down. There was that point 5 comma 74,534.83. Okay, so at 5, it's up here about 75,000. That's about right there. Okay, so here's my graph. It should be a curve, and it's going to like keep going up and up and up. Okay, so after 5 years, there's $74,534.83 in the account. And I know that because my graph showed me that point right there. Example number 5, last one, says Sally invests $1,000 into an account with an interest rate of 5%. What is the account balance after 3 years? Okay, so one thing I want to point out, she invests $1,000 into an account one time. This is a one-time investment. One more thing I want to point out, is this being compounded? No, it is not being compounded. This is simple interest. It's been a couple days since we did this. So remember this formula, interest equals principal times rate times time. Okay, so I'm going to find the interest by taking the principal. The principal is going to be that $1,000 that they invest. And we're going to multiply that by the rate and the time. The interest rate is 5%. Remember to move the decimal. So that'll be 0.05. And the time says 3 years. Now, if you multiply these, 1,000 times 0.05 times 3, we will find that the interest equals 150. Okay, now remember, for simple interest, all that means is that the interest is $150. You take the original amount that you started with plus the interest that is earned. Okay, so they started investing that $1,000. They didn't lose it. They still have $1,000, and then they earned $150 in interest. So the balance in the account is $1,150. And again, I used this formula because there was no compounding. It was just simple interest. All right, should be ready to do the practice. Make sure you pay attention to which formula do I use when. That is part of your skills check today.